Let's continue. Let's talk of static friction now. See, kinetic friction is easy to decide. The direction of kinetic friction is easy to decide, and the magnitude is simple, which is mu times n. And the equation is mu times n times Vr minus Vr cap. So kinetic friction is easy to decide and is given by Fk is equal to mu k times n minus Vr cap. So it is opposite to relative velocity of the block with respect to the surface, and magnitude is mu times n. But static friction is not so. Static friction is self-adjusting force. For static friction, what you have to presume is, okay, let's see the case. I've got a block, I've got a platform which is moving with an acceleration a. All right, mass of the block is m. If there were no friction between the block and the plank, block would remain there itself, and the plank would slide underneath it. All right, so plank would slide beneath it, but block would remain there itself with respect to ground. With respect to the car, this would go towards left with an acceleration a. Okay, now let's say there is friction, and let's say the block is going along with the plank. If the block is going along with the plank, that means block is also accelerating towards right with a naught. If I say block is also going along with the plank, block is also accelerating with a naught towards right. So if I draw the FBD, normal reaction, mg, these do not contribute to the horizontal motion because they are perpendicular to the horizontal surface. N balances out mg, so n is equal to mg in this case. The only possible force responsible, which can be responsible for horizontal acceleration, is friction. So friction is supposed to act forward. So static friction is forward. Asha, is there kinetic friction or static friction first of all? There is no relative motion between the surfaces. So friction is definitely static. If there is relative motion, friction is kinetic. If there is no relative motion, friction is static. Friction could be zero also, but it is static friction. But if there is relative motion between the surfaces, it is definitely kinetic friction. Here, there is no relative motion between the surfaces. Body is moving, definitely moving, but there is no relative motion between the surfaces. This body is moving with respect to ground, but with respect to the surface on which it is present, on which it is kept, it is not moving with respect to that surface. So when there is no relative motion, no kinetic friction. Possible friction is static friction. To decide static friction, what I do, I see this from ground frame. Here is the FBD. Here is the MAD. Only possible force for this acceleration to be produced is friction. That means friction has to be forward. So static friction has to be in forward direction. All right. Now let us say I apply some force up here. All right. This is not required. I apply some force here. And there is no friction. All right. There is friction over here and there is friction over here as well. This is the rough surface. This is also a rough surface. I have to determine the direction of friction. In such cases, I don't know whether the particle is moving or not, right? Initially, particles are at rest. So there is no relative motion between the surfaces. So friction has to be static in nature. Once the particles start moving, then you've got kinetic friction comes to picture. Till then, it's static friction itself. Now, how to decide static friction is presume all the surfaces are smooth. Presume all the surfaces are smooth. and determine in what direction is the block tending to move. If all the surfaces are smooth, this block tends to move towards left. This block will tend to move towards right. So friction on this block is towards right. Friction on this block is towards left. Simple. Reaction of this is on this one towards right. Reaction of this one is on ground towards left. This is friction, 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 friction. Presume all the surfaces are smooth. Determine in what direction will the block tend to move. If the surfaces are smooth, if I pull this one, this block is pulled towards left. This string over here will pull the upper block towards right. So upper block will tend to move towards right. Lower block will tend to move towards left. So friction on the upper block is towards left. Friction on the lower block because of ground is towards right. And it's an action reaction pair. I always told you friction has an action reaction pair. It's a real force. It's not a pseudo force. So it will always have an action reaction pair. If this is an action, its reaction is on lower block towards right. If this is the action because of ground, its reaction is on ground towards left. Alright. So I should use the same logic in the previous case also, where I've got a car accelerating with A0. So this is also accelerating with A0 along with it. But if I see with respect to the car, we have reduced the direction of friction with respect to ground, which turned out to be towards right. How do I say that? Only possible force which is responsible for its horizontal acceleration is friction. Effect is towards right. So cause should also be towards right. Effect, which is acceleration, is towards right. So force causing that acceleration should also be towards right. But if I stand on this car and observe the block, presume all the surfaces are smooth. So presume the surface is smooth. I will decide which friction. I will decide direction of friction. I know which kind of friction. It's static friction for sure, because there is no relative motion between the surfaces. But direction of static friction is to be decided. How do I decide? When I stand on this one, with respect to ground, we have decided already, which is towards right. So with respect to this platform also, I should get the same thing. With respect to this platform, pseudo force acts towards left, which is m times a, right? Because acceleration of the reference frame is to a towards right, pseudo force is ma towards left. If I presume that all surfaces are smooth, this block will tend to move towards left. Friction will be towards right. Same direction of friction as from ground. All right. Reasoning is different, but the conclusion is same. All right. So whenever you are going to decide friction, first see if there is relative motion between the blocks, between the surfaces. If there is relative motion, it's kinetic friction. Kinetic friction is easy to handle because it's opposite to the direction of relative motion. But if there is no relative motion, see if it's going to be static friction. Now, if it is static friction, you have to decide direction and magnitude of static friction. Static friction direction is decided by presuming all the surfaces to be smooth and observing in which direction will the body tend to move. If the body tends to move towards left, friction will be towards right. If the body tends to move towards right, friction will be towards left. All right, then you draw the direction of friction. And this will counterbalance the external force. What is the external force in this reference frame? And always, whenever you are going to decide static friction, stand on the surface on which the body is moving. Once you stand on the surface on which the body is moving, you draw the FBD. Net external force is counterbalanced by static friction because it's a test with respect to the surface. If surface is accelerating, I'll have a pseudo force, additional pseudo force. So the pseudo force is counterbalanced by F. So F is equal to ma in this case. Now let us do the same thing again with let's find the equations now. I've got a block. I've got a plan which is moving towards right with an acceleration a0. Block is of mass m. Coefficient of friction is mu. So with respect to ground, I draw the FBD and MAD. M0, acceleration, normal reaction, mg. Because acceleration is towards right, the only possible force which can act horizontally is friction. Friction is supposed to be towards right. All right. What is the limiting value of the friction? Mu n. What is n here? Mg. So mu mg is the limiting value of the friction. So Fs will be less than or equal to mu mg. But what is the value of Fs here? From FBD and MAD, I have got Fs is equal to mass into acceleration, right? Because this is the cause and this is the effect. F is equal to mass into acceleration, mass into effect of it. So mass times acceleration is the force. So friction is equal to mass times acceleration from ground plane. So it is supposed to be less than mu mg. All right, this we'll talk about it later. Limiting value is mu n, but force right now is m into a. All right. With respect to this platform, I draw the FBD. I've got normal reaction same. Real forces will be there as it is. MAD will change. Pseudo force will come into picture. Pseudo forces m into a naught. Because this particle is at rest with respect to the plank I'm standing on, the pseudo force is to be counterbalanced by some force. That is friction. For that to be counterbalanced, my friction is supposed to be towards right, Fs. Because it's being counterbalanced, Fs minus ma naught equal to 0. So Fs is equal to ma naught. I got the same value of force, frictional force, ma naught and ma naught. But it is sometimes easier to do using a reference. This is reference frame. But it's good to do both reference frame while practicing. While practicing, it is good to do from both reference frames. But while in exam or with practice, you will get to know which frame to choose, which is better to choose, which frame is better to choose, whether it's accelerated frame or ground frame, inertial frame or non-inertial frame. All right. Okay. All right. So this is a case of how static friction is decided in this case. All right, let's go ahead with some exam. Let us see what is happening here. This is M naught. This is M1, M2, M1, M2. Coefficient of friction is mu. Let's see what is happening, what could happen. All right. If this were frictionless, or initially particle is at rest, so no kinetic friction. So static friction will be there, which is self-adjusting. It can adjust itself to a certain value, which is called limiting value, beyond which it cannot adjust. It cannot oppose it cannot counterbalance the external force beyond a certain value, which is limiting friction. Students, are you all following?
Yes, sir.
All right.
Yes, sir.
Okay. Okay. Good. Good. Thank you. So, if there were no friction, this block will have a tendency to slip downward. This will come downward, go rightward. This will come downward. This block will have a tendency to slip towards right. So friction will be towards left. All right. So friction is towards left. And how much is the friction now? That's what I have to calculate. First, I'll find out whether it will start moving or not. All right. So condition for it to start to move. Here it's M1G. All right. I'll draw the APD separate. T M1G. If it is not moving, T is equal to M1G. And for this block, T friction, normal reaction, M2G. T is equal to M1G here. So T equal to M1G. If M1G is greater than or equal to limiting friction, what is limiting friction? Mu
If
times N, mu
yes,
M2G,
sir.
mu M2G. Then it will move. So if m1 is greater than or equal to mu times m2, only then the particles will start moving. If this is less than this, m1 is less than mu m2, in that case, particles will not move. That time, my static friction is in the picture, which is self-adjusting. And the value of static friction will be equal to, I stand on the surface on which the block is kept. I draw the FBD of it. I see all the external forces. My friction will counterbalance that force. All right, let's do that. This is anyway T is equal to m1g because it's at rest. So this is m1g. When I stand on this surface and draw the FBD of this particle, see, always, whenever I'm going to decide direction of static friction or magnitude of static friction, I stand on the surface of this I stand on the surface on which the block is kept. All right. So block is kept on this surface. I'll stand on this surface and I draw the FBD of this one. So when I draw the FBD of this, one is m1g, one is friction, normal reaction m2g. Normal reaction is counterbalanced by m2g, and friction is to counterbalance m1g. So friction will be equal to m1g. All right. As long as it is not moving, it is equal to m1g. Once it starts moving, it is equal to mu m2g. All right. Once the particle starts moving, my friction is mu n, which is mu m2g. Before that, it is less than mu n, and that is equal to m1g because it's counterbalancing the external force. Particle is at rest with respect to the surface on which it is kept. Is it clear, students? Yes, sir.
Yes, sir.
Okay. I have a block, right? This is 10 kg block. This is a force F applied, which is 40 Newton at an angle of 37 degrees, and value of mu is 1 by 2. All right. This is a scenario. I have to determine whether the block will move or not, and if at all it moves, what's the acceleration of the block? Or I have to, in short, I have to determine the acceleration of the block, whether it is zero or it is non-zero. How will I determine? Net force is equal to mass times acceleration. So any Newton's law problem starts with a reference frame. There's only one reference frame here, ground frame. There's no accelerated reference frame here. So I'll just choose ground frame as the reference frame. I'll draw the FBD of the particle. I'll write F is equal to ma. I'll get the acceleration. That's it. Simple. But then I have to decide the direction of friction, right? So when I stand on this surface, I see the block. If there is no friction, block will tend to move towards right. If it tends to move towards right, friction is towards left. Static friction will be towards left. And if at all the particle starts moving, kinetic friction is definitely towards left. All right. Now,
Yes, sir.
yeah. All right. Now, so I have to determine components: horizontal component, vertical component, Fx, Fy. I'll draw the FBD now. I'll draw here itself. I've got normal reaction, Mg. Friction is definitely towards left, Fs. Now I have to determine what is the limiting value of the friction. If the limiting value is more than the external applied force, then it will self-adjust to counterbalance the external force. If limiting value is less, and external force applied is more, relatively more, then it cannot counterbalance, it will start moving. All right.
Yes,
So let us
sir.
find out the limiting value first. How do you find the limiting value? Mu into n is my limiting value. Now, what is n? N is not mg here. Look at this. N is not mg. I take the components of 40 along horizontal and vertical. Vertical component is Fy, horizontal component is Fx. So n is equal to, so n plus Fy is equal to mg. So n is equal to mg minus Fy. What is Fy? 10g, which is 100, minus 40 sine 37. What is sine 37? Remember this triangle. 3, 4, and 5. Sine 37 is 3 by 5.
Yes, sir.
So 100 minus, how much is it? 40 into 3 by 5 is how much?
24.
Alright, so 100 minus 24 is
76.
76, sir.
76. So my normal reaction is 76 now, right? So FL is equal to 1 by 2 times 76. Why is it 1 by 2? Because mu value given is 1 by 2. So what is 1 by 2? Half of 30, 76 is 38.
38.
Right. Now that is limiting value. But what is the horizontal force applied? F cos 37. What is cos 37? 4 by 5.
4
So
by 5.
40, right. 40 into 4 by 5, which is equal to 32. 32 Newton. So horizontal applied is 32 Newton, but limiting value is 38 Newton.
Yes,
So will the
sir.
particle move? No, it will not move.
No,
And what is the
sir.
value of friction? Yes. So what is the value of friction? It will be equal to 32 Newton. Because
Yes,
it's still
sir.
less than limiting, it will self-adjust itself to the limiting value. Sorry, external value, external force. So acceleration of the block is 0. So is the particle moving? No. It's at rest, it will remain at rest. Alright, is it okay? Should I repeat the argument?
Yes, sir.
I've got a block, 10 kg block, force applied is 40 Newton at an angle of 37 degrees with the horizontal. I have to determine the acceleration of the block. In other words, acceleration is 0. If it is non-zero, how much is the acceleration? So I have to determine whether the particle is moving or not. For that to be determined, I have to determine whether my limiting friction is reached or not. If limiting friction is reached, block will start moving. If limiting friction is not reached, my friction will self-adjust to keep it at rest. So how do you find to find friction? I'll find limiting friction first, which is mu times n. To find n, I'll use the FBD. N plus Fy is equal to mg. N is equal to mg minus Fy. I'll get some value of n. I plug in over here. I'll get value of limiting friction as something. That limiting friction I find out. I compare it with the horizontal external force. Net horizontal external force. What is the net horizontal external force? 40 cos 37, which is 32. Limiting turned out to be 38. Horizontal turned out to be 32, which is less than limiting. So my friction will self-adjust to 32. And the block remains at rest. Alright. Now let's look at another one where we have mu s and mu k. Till now we were dealing with situations where mu s is equal to mu k. Alright, I was giving only one value of mu, coefficient of friction. When only one value of mu is given, it is to be presumed that mu s is equal to mu k. That's coefficient of static friction is equal to coefficient of kinetic friction. But then I've got another situation where 0.5, 0.3. I have to determine the acceleration of the block. Mass of the block is 10 kg. Mu s is 0.5. Mu k is 0.3. Alright, always remember mu s is greater than or equal to mu k. Alright, that's an experimental fact. Now, applied force is 51 Newton. So, will the particle move? If the particle moves, with what acceleration? So, what do I do? What is the strategy? I stand on the surface on which the particle is moving, right? Ground frame. I draw the FBD. All right, that's the first step. Any Newton's laws problem, you first draw the FBD. Things become little simpler. But I have to decide the direction of friction, for which I'll presume the surfaces are smooth. If the surface is smooth, my external force is towards right, or block will tend to move towards right, friction will be towards left.
Yes,
All
sir.
right. Now I will have to find out the limiting value of the friction. If that external is beating this limiting value, this will start moving. So what is the limiting value now? Mu s into n, not mu k into n. So mu s into n is half times 100. All right, I didn't draw the FBD, right? I've drawn it in my mind.
50, sir.
Right,
Friction.
right. So because n is equal to 100 g, 10 g, n is equal to 100. So limiting value FL is equal to 50 Newton. Okay. So if limiting value is 50 Newton, but applied is 51, it cannot
Yes,
self-adjust. It
sir.
can at max it can self-adjust to a value of 50, but applied is 51, so it will start moving. Once it starts moving, mu k will come into picture. Kinetic friction comes into picture, where I have to consider mu k n, where mu k is 0.3. So what is it Fk now? Mu k times n,
Sir, it is 30 newtons.
30 Newton. So net force on the block now is Fk towards left, 51 towards right, and 10 kg block. So 51 minus 30 is equal to 10 into A. So 21 is equal to 10 into A. A is equal to 2.1 meters per second square. This is all simple. F is equal to ma, nothing more than that. But you have to decide what kind of friction acts. As long as I first think it is static, if my external force is beating the limiting static friction, it will start moving. The moment it starts moving, Fl will not come into picture, Fk will come into picture, where Fk is mu k into n, which is 30 Newton. So 51 minus 30 is equal to mass into acceleration. So acceleration I get it as 2.1 meter per second square. Is it okay?
Yes, sir.
Everyone?
Yes, sir.
Or do you want me to repeat the argument? I'll do it.
Sir, can you repeat FK?
Okay. See, I'll block is at rest initially. So it's definitely not kinetic friction. It is supposed to be static friction. The moment I see the block FBD, I'll find out the limiting friction, limiting value of the static friction, which is FL is equal to mu S into N, which is 50 Newton. Because N is 100 G, 100 here, 10 G. So mu S is 50 Newton. But applied is 51 Newton. That means the block cannot resist being at rest, moving. So it has to move because external is beating the limiting value. Once it starts moving, Fk comes into picture, not Fl. Friction suddenly drops. If you remember the graph as well, this is the friction. It suddenly drops after at this point. There's a kink there. I told you there's not a smooth graph. There's a kink there. For practical scenarios, there's a kink there. For mu s is equal to mu n, it's a constant smooth graph. But for mu s not equal to mu k, there's a kink there. Mu k is always less than mu s, less than or equal to mu s. So mu k comes into picture, Fk comes into picture, which is Fk. I have to find out Fk now. What is Fk? Mu k into n. Mu k given is 0.3. Or even if I don't say which is mu k mu s, higher level, greater level is greater value is 0.5, which is mu s. Relatively lesser is 0.3, which is mu k. So mu k into n is 30 Newton. So Fk is 30 Newton. So net force on the block now is 51 and 30. 51 minus 30 is equal to mass into acceleration. So 21 is equal to 10 into A is equal to 2.1. meter per second square.
Okay, sir.
Okay. Now look at the next question. I have a 10 kg block. Coefficient of static friction is mu, S, or mu is 1.5, sorry, 0.5. All right. There's no force applied. What is the friction value? What is the value of the friction on the block? There's no force applied.
50, sir.
Friction is 50 or limiting
No,
value is 50?
sir.
Limiting value
Zero,
is
sir.
50.
Zero.
Zero, right? Friction is zero. If there is force, it will start moving. It is not moving, I said. It's at rest. It's kept on the surface. How can friction be there? I mean, there's no net external force. Static friction is self-adjusting. It will adjust to the value of net external force. Net external force is zero. So static friction is zero. So
Yeah,
friction
sir.
is zero.
Limiting
Limiting value
value.
is 50.
Yeah, sir.
Sorry?
I'm saying limiting value, sir. I'm telling.
Yeah, limiting value is 50. But now I apply 100 Newton. What happens to the block? Will the block move?
Yes, sir.
With what
Yes, sir.
acceleration? With what acceleration? I'll draw the FBD. Simple. 100 minus 50 by 10. 5 meter per second square.
Yes, sir.
But now the question is, what should be the additional force applied on the block from above? Additional force Fx to be applied such that the block doesn't move. What is the minimum external force to be applied vertically on the block? With what force should I press the block such that it doesn't move? It makes sense, right? The question makes sense. పైనుంచి నుంచి నేను ప్రెస్ చేస్తే నార్మల్ రియాక్షన్ ఇంక్రీజ్ అవుతుంది. నార్మల్ రియాక్షన్ ఇంక్రీజ్ అయితే లిమిటింగ్ వాల్యూ ఇంక్రీజ్ అవుతుంది. లిమిటింగ్ వాల్యూ ఇంక్రీజ్ అయితే మై సెల్ఫ్ అడ్జస్టింగ్ రేంజ్ విల్ ఇంక్రీజ్. If my limiting value is more than 100, then will not move. All right. I repeat. పైనుంచి ప్రెస్ చేస్తే when I press it from above, normal reaction increases, because if I press it, block is being pressed, this ground will press it upward. Normal reaction increase అవుతుంది. So if normal reaction increases, mu n increases, limiting value increases. If limiting value is increases to an extent of greater than 100, then it can self-adjust to 100 and counterbalance 100. It will not move then. Right? So all I have to do is see to it that limiting value is equal to 100, at least 100. So FL should be less than or equal to 100. What is FL? Mu times N. So less than or equal to 100. What is N now? N is equal to mg plus fx or fx. So N is equal to 100 plus fx. So mu times, which is half, 100 plus fx is less than or equal to 200. So fx should be less than or equal to 100. So if I apply force, sorry, it should be greater than or equal to 100. Students, it's supposed to be greater than or equal to 100. Only then the question makes sense, right? He's asking minimum value of normal reaction. Sorry, fx. So fx is greater than or equal to 100. So minimum value of fx is 100. Do you all understand this question? Think about it. Think about it. I'll be back in a minute. If you have got any doubt, please ask. Yeah, any doubts? Any doubts, students?
No, sir.
Okay. Now I've got a block which I'm seeing from above. So this is gravity into the plane. So one mass of the block is m. Applied is 20 Newton, 15 Newton in this direction, perpendicular directions. All right. I have to determine it is observed that the block is not moving. All right. It is observed that the block is not moving. I have to determine the value of the static friction. Because the block is not moving, the question is on static friction itself. I have to determine the value of static friction acting on the block. How will I determine? To determine static friction, I'll have to presume, I have to stand on the surface on which the block is kept. I'll draw the FBD. Static friction will try to counterbalance the net external force acting on the block. So all I have to determine is the net external force acting on the block. So 20 Newton is acting this way, 15 Newton is acting downward this way. So net resultant force will be this way, 20 square plus 15 square under root. How much is that?
25, sir.
25, sir.
25, right? If that is 25, my friction should be opposing this external force. So my Fs or frictional force is static here, which is opposing 25 Newton. So what is the value of friction now? It is 25 Newton, exactly opposite to the external force. What is friction now? This is 15, this is 20. If this is theta, tan inverse of 15 by 20 with the horizontal. All right, friction is a vector. Force, it's a force, it's a vector. I need direction and magnitude. Magnitude turns out to be 25 because it is counterbalancing 25. It is in the horizontal plane, opposite directed to the net external force. External force is directed 25 at an angle of tan inverse of 15 by 20. So it will be this angle, if this theta, this is also theta, vertically opposite angles. Sorry, just opposite angles. Is it correct? Tan inverse 15 by 20? Yeah, tan theta is 15 by 20. Yeah, yeah, tan inverse of 15 by 20. So theta is 15 by tan inverse 15 by 20 with a horizontal. Is it okay? And what's the normal reaction on the block? Can you tell me what's the normal reaction on the block? Look at this. It's horizontal plane. Be careful. Gravity is inward. What is the normal reaction on the block? Draw the FBD. It's a mass of 10 kg, let's say. What is the normal reaction on the block?
10 kg or sir?
10
10
kg
G,
is
10 G.
mass. Sorry?
10 G.
10 g, right. Because this is horizontal forces. My normal reaction
100
is
Newton.
100 Newton, right? 10 g, 100 Newton. So normal reaction is upward. Mg is downward, which is 10 g is downward, which is counterbalanced because there is no motion vertically. So N self-adjusts to counterbalance mg. So N is equal to 10 g, 100 Newton. That's right. All right. Okay. Now let's come to another question, which is another scenario, not question. I've got a wall. I've got a block. I just touch this to the wall and leave it. All right. Mass is m, or mass is m naught. Coefficient of friction is mu. What is the friction on the block? Direction of friction and a value of friction. It's a vertical wall. What do you think is the friction? See, friction, I have to find out the limiting value first. I mean, I have to first presume there are no external forces. Sorry. All the surfaces are smooth. There are external forces, but surfaces are smooth. So surface is smooth, I'll presume. External force is mg downward. So limiting value will be
mu m naught g, sir.
mu times n,
Yeah,
not
sir.
m naught g. Mu times n. What is the normal reaction here? If I draw the FBT of the block, normal reaction is 0. n ఇలా డ్రా చేస్తే mg ఇలా ఉంటుంది. ఫ్రిక్షన్ ఒకవేళ ఇలా ఉంటే కూడా f is equal to mu times less than or equal to mu times n ఉంటే కూడా, ఫ్రిక్షన్ ఇలా ఉంటే కూడా, సెల్ఫ్ అడ్జస్టింగ్ ఉంటే కూడా, normal reaction is 0 because horizontally there is no acceleration. Only possible force that can produce acceleration is normal reaction in the horizontal direction. There is no acceleration, so no normal reaction. Normal reaction is 0, that means my limiting value is 0. Friction is 0. Let's say
Yes, sir.
if I leave some particle like this, if I leave this, it falls directly, no? Under G. There's no friction on it because normal reaction is 0, right? But if I press it like this, ఇలా ప్రెస్ చేశాను అనుకోండి, then normal reaction comes into picture. Normal reaction is non-zero, because of which my limiting friction will increase. Fl will be there. Now mg, that is counterbalanced by, mg is counterbalanced by static friction. But if I release my finger, normal reaction becomes 0, that slips out. All right. Okay, that's the scenario. What's the scenario now? If there is no normal reaction, friction becomes 0 because friction ultimately is mu times n, whether it's kinetic or static limiting, it's mu times n. If normal is 0, normal itself is 0, no friction. It is as bad as a smooth surface, or it's as good as a smooth surface, depending on the situation. Like I say, good or bad, depending on the problem is easy or difficult. All right. Now look at this. What I do, instead of having this fixed wall, I'll place another block here. Okay, before that. How much force should I apply? Fx, such that the block doesn't slip. For block not to slip, how much force should I apply Fx? What happens if I apply Fx? So look at this. If I don't apply any force, it is slipping down, right? It's a small block, right? It's slipping down. But if I apply some force like this, but if I don't apply enough force, it will slip down. But if I apply enough force, ఎక్కువగా ప్రెస్ చేస్తే అక్కడే ఉంటుంది. So what is that condition? What is the minimum effects that I should apply for it not to slip? కొంచెం అప్లై చేయకుంటే కింద వచ్చేస్తుంది, కొంచెం అప్లై చేస్తే కూడా కింద వస్తుంది. బట్ విత్ లెసర్ యాక్సలరేషన్. మొత్తం గట్టిగా అప్లై చేస్తే అక్కడే ఆగిపోతుంది. ఐ రిపీట్, అప్లై చేయకుంటే మొత్తం కిందకు వచ్చేస్తుంది విత్ జీ. కొంచెం అప్లై చేస్తే ఇట్ కమ్ డౌన్ విత్ లెసర్ యాక్సలరేషన్. ఇంకా గట్టిగా ప్రెస్ చేస్తే ఇట్ విల్ స్టే దేర్ ఇట్సెల్ఫ్. రైట్. సో ఐ హావ్ టు ఫైండ్ అవుట్ దట్ ఫోర్స్, మినిమం ఫోర్స్ విచ్ విల్ మేక్ ఇట్ స్టే దేర్ ఇట్సెల్ఫ్. ఎలా చేస్తాను? లుక్ ఎట్ దిస్. ఐ ఫైండ్ ద లిమిటింగ్ ఫ్రిక్షన్.
సార్,
ఎస్,
నేను ఒక్కటి అనుకుంటున్నా, ఐ మీన్ ఆ ఫోర్స్ m naught g అవ్వచ్చా?
అక్కడ మ్యూ కూడా ఉంది.
ఓకే సార్.
Yes, let's see. ఎంత ఉంటుంది, let's see. So, see, చూడండి, డైరెక్షన్స్ ఆర్ మినిమం ఆర్ మాక్సిమం ఉంటుందా, అలా క్వాలిటేటివ్లీ రీజనింగ్ తో చేయొచ్చు. బట్ వాల్యూ తెచ్చుకోవడానికి విల్ హ్యావ్ టు గో ఫర్ ఈక్వేషన్, safer side. All right, once you are quicker in equations, you can quickly jump and skip the equations and then get to the answer. All right, that will come with practice, not a problem. But students, what I observed is you are not practicing. Like, be it any subject, you are not getting time to practice. For whatever the reason, you are not getting time, but you people are not practicing. That's a drawback. All right, we'll talk about it later. But okay, look at this. Fx ఇలా ఉంది, నార్మల్ రియాక్షన్ ఇలా ఉంటుంది, ఫ్రిక్షన్ ఇలా ఉంటుంది, ఎఫ్ఎల్ ఇలా ఉంటుంది, లైక్ ఫ్రిక్షన్ ఇలా ఉంటుంది. లిమిటింగ్ వాల్యూ ఎంత ఉంటుంది, మ్యూ టైమ్స్ ఎన్. సో మ్యూ టైమ్స్ fx. Mu times fx should be greater than or equal to mg. అప్పుడే కదా ఎక్స్టర్నల్ ఫోర్స్ కి కౌంటర్ బ్యాలెన్స్ చేయడానికి నాకు లిమిట్ ఉంటుంది. సో fx, where fx is mu times n should be greater than or equal to mg. Here n is equal to fx. So mu times fx is equal to mg. fx mu half అనుకుంటే fx is greater than or equal to 2mg. Or mass is 10 kg అనుకుంటే this is greater than or equal to 200 Newton. సో నేను 200 Newton అప్లై చేస్తే అప్పుడు, so it's greater than mg. There is mu mg, it's not mg. All right, Vignesh, have you noticed mu into mg వస్తుంది. Sorry, mg by mu వస్తుంది. mu fx is equal to greater than or equal to mg. fx is equal to mg by mu. All right, so mu factor వస్తుంది అక్కడ. All right,
Yes, sir.
okay, now look at this. That means if I press it 200 at least, less than 200 press చేస్తే ఏమవుతుంది, limiting will be less than m0g. అప్పుడు m0g will beat limiting friction, slide down. బట్ నాకు లిమిటింగ్ m0g కంటే ఎక్కువ ఉంటే m0g is being self adjusted, I mean m0g is being counterbalanced by self adjusting static friction. So the mass, let's say some 100 grams అనుకుంటే ఇలా ప్రెస్ చేసినప్పుడు, if I press it with 2 mg, then it will stay there. If you press it little less than 2 mg, it is sliding down. Okay, I can feel the force తగ్గిచేస్తే కింద వచ్చేస్తుంది. బట్ ఫోర్స్ అలా అక్కడే పెట్టాలంటే ప్రెస్ చేయాల్సి వస్తుంది. కానీ ఎక్కువ ప్రెస్ చేస్తే అక్కడే ఉంటుంది, బికాస్ లిమిటింగ్ ఇస్ ఎంజీ, సారీ మ్యూ ఎంజీ, మ్యూ ఎన్. ఇప్పుడు నేను n 400 అప్లై చేస్తే ఏమవుతుంది, రిక్వైర్డ్ ఇస్ 200, బట్ 400 అప్లై చేశాను, అప్పుడు ఫ్రిక్షన్ ఎంత ఉంటుంది, మ్యూ ఎన్ ఉంటుందా, నో, మ్యూ ఎన్ ఇస్ ద లిమిటింగ్ వాల్యూ. ఫ్రిక్షన్ విల్ బి కౌంటర్ బ్యాలెన్సింగ్ ది ఎక్స్టర్నల్ ఫోర్స్ mg. సో mg ఉంటుంది ఫ్రిక్షన్ ఫోర్స్, లిమిటింగ్ వాల్యూ మ్యూ ఎన్ ఉంటుంది, బట్ రిక్వైర్డ్ ఇస్ ఓన్లీ 10 kg, 10g నా. So required is 10g, but limiting now is 200. FL is 200, but it will self adjust 200. ఇది n is equal to 800 చేస్తే, like fx if I apply to be 800 Newton apply చేస్తే ఏమవుతుంది, లిమిటింగ్ వాల్యూ ఇంక్రీజ్ అవుతుంది, but it will self adjust to mg. All right, okay, now let's come back to the actual question. Not come back, let's come to the actual question now. The question is this: I've got, instead of a wall here, I've got a block. Which is moving towards right with an acceleration a. And the coefficient of friction is mu between the surfaces, mass is m0. It's going towards right with an acceleration a. I have to determine the minimum acceleration a such that this block will not slide. This can be done using two reference frames. One is ground reference frame, accelerated reference frame. But you see, accelerated reference frame is easier to understand. All right, we'll see, we'll do both, but we'll do accelerated first. అయితే ఏం చేస్తాను, I stand on the surface and I draw the FBD of the block. When I do that, what is the FBD of the block? M0G pseudo force, sorry, mg pseudo force ma0 normal reaction friction పైన ఎందుకు ఉంటుంది, కింద ఎందుకు ఉండదు?
కింద ఫోర్స్
Because
లాగుతుంది సార్.
no, presume surfaces are smooth, it is tending to slip downward, friction will be upward.
Yes, sir.
All right, so mg వల్ల friction mg వల్ల రావట్లేదు, mg వల్ల it is tending to slip downward, so friction is, it will try to counterbalance the external force, it will be upward. Now ఇప్పుడు what is the limiting value of the friction? Fn is equal to mu n, mu times n, which is, what is the n value of n here? What is the value of n here?
MA0.
ma0, because it's at rest horizontally కదా, ఈ సర్ఫేస్ మీద నిలబడితే,
Yes, sir.
surface మీద నిలబడితే block is not moving horizontally, it is going along with the block. This huge block is going, small block is going along with the huge block. So this block is not moving horizontally with respect to this accelerated reference frame. With respect to ground frame, it's moving towards right. That's fine. But with respect to this frame, pseudo force valla normal is counterbalanced. So n is equal to ma0. So mu into ma0 should be greater than or equal to mg. So m gets cancelled out. Acceleration is equal to g by mu. All right. This is from accelerated reference frame. Ground frame నుంచి చూద్దాం. Ground frame నుంచి చూసినప్పుడు I'll draw the FBD again. Real forces will be as it is, normal reaction. mg, pseudo force ఉండదు ఇప్పుడు. But MAD is different. MAD is acceleration here. ఇక్కడ acceleration was 0. Horizontal acceleration was 0. But here you have got a horizontal acceleration. And friction ఇలా ఉంటుంది. So Fl is equal to mu into n. But what is n here? N is equal to m into a. N is equal to m into a. ఇక్కడ ఎలా ఉంది? N minus ma equal to 0. Look, these two equations mean different things in different reference frames. N is equal to ma, n minus m equal to 0. Mathematically same. N minus 2 equal to 0 or n is equal to 2, mathematically same, but mean different. Ikkada particle is at rest, it's in equilibrium, horizontal equilibrium. Ikkada it's not in equilibrium. It's net force is acting and creating an producing an acceleration of a0. You understand the difference between these two equations? I have repeatedly told this before. You see the difference between these two equations? N is equal to ma0 and n minus ma0 equal to 0.
Yes, sir.
Everyone?
Yes, sir.
Okay, good. All right, so n is equal to ma here. So mu times n, which is mu times ma, should be greater than or equal to mg. So m gets cancelled out. Mu into a is equal to g, I mean greater than or equal to g. So a should be greater than or equal to g by mu. I get the same result here and here. All right, here if at all you miss something, I mean you'll get the same answer whether you do it from this frame or this frame, but you will, with practice you will see this frame is comfortable because pseudo force వేసేస్తే నాకు particle equilibrium రావచ్చు, or pseudo force, you'll see the pseudo force, handling with pseudo force is easier. So but you should be comfortable in both the ways. రెండు ways లో ఆలోచించడం రావాలి. What is the difference in FBDs here? ఇక్కడ pseudo force వచ్చింది, ఇక్కడ pseudo force రాలేదు. But what is the difference now? MAD లో difference ఉంది. Mass acceleration diagram లో difference ఉంది. Acceleration is 0 here, acceleration is a0 here. With respect to ground, it's moving with a0. With respect to the frame, acceleration is 0. Okay. Yes.
How that equation seems,
Which
n
equation?
is equal to ma0.
ఇదా దీంట్లో గ్రౌండ్ ఇది అర్థమైందా? n minus ma0 equal to 0.
Yes, sir. Yes,
Net
sir.
force is equal to mass into acceleration రాస్తాను, right?
Yes, sir.
ఇక్కడ కూడా net force is equal to mass into acceleration రాస్తాను. What is the net force here? Horizontal direction లో n kada.
Yes, sir.
That force is equal to mass into acceleration in the horizontal direction. So n
Yes,
is equal to
sir.
mass into, is it okay?
Yes, sir.
Net. So చూడండి, ఏ ప్రాబ్లం అయినా, if at all you're not getting any idea, choose a reference frame, draw the FBD and MAD, write F is equal to MA. That's it. Things will be simple. Choose a reference frame, draw the FBD, write F is equal to MA. Here F is equal to mass into 0. Here F is equal to mass into A. That's it. And FBD is, FAD and MAD are different. All I have done is I've chosen a reference frame. Here accelerated reference frame, here non-inertial reference frame, inertial and non-inertial reference frame. ఇనర్షియల్ చేసుకున్నప్పుడు నాకు రియల్ ఫోర్సెస్ ఉండే, విత్ యాక్సలరేషన్ కూడా ఉండే. ఇక్కడ ఎంఐడి డిఫరెంట్ ఉండే. ఈ నాన్ ఇనిషియల్ డిఫరెన్స్ చూస్ చేసినప్పుడు నాకు సూడో ఫోర్స్ అడిషనల్ ఉండే. విత్ ఆల్ ద రియల్ ఫోర్స్ యాడ్ అండ్ అడిషనల్ సూడో ఫోర్స్ విత్ చేంజ్ ఇన్ ఎంఐడి. ఎంఐడి చేంజ్ అయింది ఇక్కడ, రైట్? సో ఐ రైట్ ద నెట్ ఫోర్స్ ఈక్వల్ మాస్ ఇంటూ యాక్సలరేషన్. నెట్ ఫోర్స్ ఇస్ n minus m a naught is equal to 0, m into 0. Here n is equal to net force equal to mass into acceleration. That's it. Rest all is same, right? So choose a reference frame, draw the FBD in that reference frame, and write F is equal to MA. ఆ రెఫరెన్స్ ఫ్రేమ్ నాన్ ఇనిషియల్ రెఫరెన్స్ ఫ్రేమ్ ఉంటే అన్ని రియల్ ఫోర్సెస్ తో పాటు సూడో ఫోర్స్ ఉంటుంది. అండ్ MAD will be different. There will be difference in MAD in both different in this reference frames. Accelerated reference frame, నాన్ ఇనర్షియల్ రెఫరెన్స్ ఫ్రేమ్ లో MAD డిఫరెన్స్ ఉంటుంది. అది కేర్ఫుల్ గా డ్రా చేయాలి. అది ఈ 3 స్టెప్స్ చేస్తే ఏ ప్రాబ్లం అయినా సాల్వ్ చేయొచ్చు. Alright, students. That's all for today. Have a great day. But try to practice things not in all the try to maintain consistency in all the subjects. మీరు practice కి టైం దొరకట్లేదు అనుకుంటా, but I don't know what's the reason. But you people are not practicing. Alright, you are able to understand the things in class. But after the class, and you're smart enough to understand quickly. That's what I've seen. మీరు తొందరగా అర్థం అవుతుంది. But after the class, you're not putting effort. You're not getting time to put effort, or you're busy with the classes, college, homework, and everything. But somehow take out time and try to think through the problems. All right. Thinking is very important, students. All right, students. Have a great day. Bye, everyone.